Okay, so the idea is to see what is the minimal polynomial, what is the idea of the minimal polynomial of a diagonal matrix. Now, remember that the minimal polynomial of a matrix contains all of its eigenvalues, and in order for a matrix to be a diagonalizable, and remember that diagonal matrix by definition is diagonalizable because you can diagonalize it with the identity matrix, and it's diagonal by itself, so this is diagonalizable because it's diagonal matrix. So the minimal polynomial of diagonalizable matrix must divide into distinct linear terms. So in the complex numbers, it always can be divided into distinct linear terms, but it also must into linear terms, but they also must be distinct, namely no repeated roots in the minimal polynomial in order for the matrix to be diagonalizable. So divide into linear terms, and then the linear terms should be distinct, namely linear terms and no repeated roots in the minimal polynomial in order for a matrix to be diagonalizable. So in the complex numbers, remember that every polynomial can be divided into linear terms, but it may be that there may be repeated roots. So let's, for example, look on this matrix for an example for a diagonal matrix. What is the minimal polynomial just by looking at the matrix? Can you know that? Of course you can. This is a diagonal matrix, so it's diagonalizable, but by that it's diagonal, as we said. So the eigenvalues of the diagonal matrix is on the diagonal, so it's 2, 7, and 8. So the minimal polynomial must contain, for example, t minus 2, t minus 7, and t minus 8. Now, it cannot be repeated, so the minimal polynomial, those are the eigenvalues. The minimal polynomial must be t minus 2, t minus 7, and t minus 8 without any power to any term. This is not the characteristic polynomial. The characteristic polynomial may be with powers to the terms, but in the minimal polynomial must be, in order for the matrix to be diagonalizable, divided into linear terms, as you can see here, multiplication of linear terms, and no repeated roots, namely each term is to the power of only 1, not 2, 3, 4, and etc. So the minimal polynomial of a diagonal matrix must be of this form. You can see t minus eigenvalue 1, t minus eigenvalue 2, t minus eigenvalue 3, and etc. for each eigenvalue, but this is the form of the minimal polynomial for a diagonal matrix because it must be diagonalizable per definition. And that's it on the minimal polynomial of a diagonal matrix.